Before we begin, I'd like to point out an error in the previous video. I had written this as r is the square root of x squared plus y squared, or r squared is the square root of x squared plus y squared. That's incorrect. The appropriate equation is that r squared is equal to the sum of those squares. You could think of r as being the square root of them, but that can be problematic. So in the previous video, that was incorrect. I apologize. But anyway, we want to do some examples of converting cylindrical to Cartesian coordinates and Cartesian to cylindrical coordinates. I also want to point out that sometimes Cartesian coordinates are referred to as rectangular coordinates, and that makes sense because you could think of them like a grid. And so, anyway, so let's take a look here. We have 2, negative pi, and negative 4. And for these, it's pretty simple. You just plug it into the formula. So in this case, we have r and theta. So that's r and theta. And z. So we just need to recover x, y, and z. So x is r cosine theta. And y is r sine of theta. So then our coordinate is -2, 0, and -4. Remember, z stays the same. Now, you might think to yourself, how do I know that this is correct? Well, think about it. You're at negative pi. So if you start on the x-axis and you go negative pi, you end up on the x-axis, but you end up in the negative part of the x-axis. So your y value should be 0, and your x value should be negative. So we end up with a negative x value, 0, and the z coordinate stays the same, so we don't really have to worry about that. So similarly, x is 6 cosine -3 pi over 2. Y is 6 sine -3 pi over 2. So that's 0. Notice that -3 pi over 2 is equivalent from a unit circle perspective to positive pi over 2. So that's 6 and then 2. And again, that makes sense. If we think of pi over 2, you have an xy axis, then you rotate up pi over 2, you should have a positive y value and 0 for the x coordinate. So over here we have -2/3 cosine 4 pi over 3, -2/3 sine 4 pi over 3. So in this one, it's a little trickier. So if you think about 4 pi over 3, so you're going to go up pi over 3, or up to almost, or just past pi, right? So you're going, it's just a little bit bigger than pi. So you go all the way down into the third quadrant. But it's a negative r, so you go kind of through that line. So if this was 4 pi over 3, you're really going in the opposite direction. So you end up back in the first quadrant. So functionally, this is equivalent to 2/3 pi over 3, 8. Those would be the same cylindrical coordinate. So it may be easier to think about this. We're in the first quadrant, so we know that x and y should end up being positive. So cosine of pi over 3 is 1/2. So 1/2 times 2/3 is 1/3. Sine of pi over 3 is square root 3 over 2 times 2/3 square root 3 over 3. And then the z coordinate stays the same. Simple enough. All right. Now, let's convert the Cartesian to cylindrical coordinates. And again, we're going to get the magnitude here, and then we're going to use this to get our angle. And then we can think about the angle that makes sense for this based upon what quadrant we find ourselves in. So in this particular case, we're in the first quadrant because x and y are positive. So we know that r is 6 squared plus 2 root 3 squared, which is the square root of 36 plus 12, which is the square root of 48, which then is 4 root 3. And then we have to find out what tangent of theta is. Well, tangent of theta is y over x. So it's 2 root 3 over 6, which if we divide there is square root of 3 over 3, which you may remember. So square root of 3 over 3 is in the case where theta is pi over 3. Again, we know that it's pi over 3 and not 4 pi over 3, which would have the same tangent. We can tell that because we know the quadrant. We know that we're in first quadrant. So our answer to this problem is 4 square root of 3 pi over 3. And again, the z-coordinate stays the same, -1. So then we want to do this one wherein x is positive, but y is negative. So that tells me I'm in quadrant 4. So r is 3 squared plus -3 squared, which is square root of 18, which is 3 square root 2. And tangent of theta is 3 divided by -3, which is -1. So again, if tangent is negative, that could either be quadrant 2 or quadrant 4. But we know from this that we're in quadrant 4, so we understand that theta is negative pi over 4. So we have 3 square root of 2, negative pi over 4, and 7 is our answer. And then finally, notice here we also are in quadrant 4. So r is 2 square root of 3 squared plus -2 squared, which is 12 plus 4 square root of 16 is 4. And tangent of theta is -2 over 2 square root of 3. That should have been -3 over 3. I apologize for that. But it comes out to the same, but still, it's important to get things correct. So -2 over 2 square root of 3 is -1 over square root of 3, which is negative square root of 3 over 3. And the only reason I use that is because we already saw that here. So if this relationship gives me pi over 3, this relationship should give me negative pi over 3. Remember, because tangent is an odd function, so it has that nice relationship. So our final result is 4, negative pi over 3, and 6. And that's how you do the conversions between rectangular and cylindrical coordinates.